Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer and aspiring software architect.
And I'm Beej, the journeyman developer sharing my journey in development. Even terrible code runs. In fact, lots of terrible code runs in production every day. However, such code is difficult to maintain, horrifying to modify, and subject to nasty problems as it ages. Like a messy house, a messy code base is nowhere you want to visit, much less a place you want to live. We've brought Uncle Bob Martin, author of Clean Code, on to talk with us and discuss a clean code base and cleaning up a code base. But before we get started, Will, what have you been fighting this week?
Yeah, I got a new monitor, and I say monitor, it's a 50-inch 4K TV. So I've got all my development environment splayed out across it. And I've spent most of a week wasting time and playing video games, and I'm fighting the desire to start something new because I just finished up the book, and it's all I can do to just actually force myself to chill out for another week or so.
Mm-hmm.
So that's the main thing going on here is like me fighting taking a break. So how about you, Bob?
Oh, me, huh? Jeez. The project I've been working on this week is episode 61 of Clean Code on cleancoders.com. That's one where I finish up the series on functional programming by writing the algorithm to solve the general Sudoku problem.
Ooh.
So that's been a bit of a challenge, but I got it done. Yeah, it was fun.
Oh,
nice.
So I just got back from North Carolina. We drove down. It's like mostly east to Asheville Sunday after church, which it's really interesting going to a town called Asheville when you tell people you're from Nashville. It gets all sorts of confusing. We hit up the Funkatorium and tried a few sours while we were there. Then spent the day Monday at the Biltmore. Y'all, that place is huge.
Yes, it is.
They had a Downton Abbey exhibit there, and that's Amanda's favorite show. So, of course, we did all the tours with that, took lots of pictures, went on the candlelight tour. Wasn't really a tour, because I was expecting, a tour guide walking you through the Biltmore with candles and stuff. Nothing like that. They just sort of let you in and dimmed all the lights.
Yeah, they don't want to walk you through that place. It is massive.
Yeah. So we also got to hang out with my former boss, Brian. He and his wife moved down there a little while ago. Brian's the one that at Developer Launchpad, you had the contest to see who could solve the problem in the fewest characters of code.
Yeah. We just wanted to know, that was a nerdy thing to do.
It was. Then on Tuesday, we drove on to Charlotte for the Lindsey Sterling concert. That was amazing, as always. She puts on such a great show and just keeps getting better. This was the first Christmas show or Warmer in Winter show that I've gotten to attend, and it was Amanda's first Lindsey concert, so it was a lot of fun for both of us. It was a little bit different because it was a Christmas show. Everyone sat the entire time, and I'm used to standing at concerts. Even at Lindsey Sterling concerts, I'm used to standing. Let's be honest, y'all. Most of the shows I'm attending, I'm down in the pit pushing and shoving. It's a lot of great exercise moshing. But speaking of exercise, let's go ahead and get into our book for book club. Chapter 2 of The Healthy Programmer, Get Fit, Feel Better, and Keep Coding is titled Bootstrapping Your Health. It starts off with a story about Andrew Wiles, who proved Fermat's last theorem in 1995. He worked alone and in secret on the mathematic conjecture. When asked how he stayed creative being alone so much, he said that he would walk every day. The author, Joe Kuttner, goes on to talk about studies that show exercise improves memory. And the next section is about how simply walking can benefit your health. As programmers, we tend to sit a lot and don't get much walking in our daily activity. And Kuttner suggests buying a pedometer to measure your steps. Of course, this book is a little bit older, and if you have a smartphone, like most of us do, and it never leaves your side, you really don't have to buy one. Most of them have that built in. He goes on in the next section to encourage spending at least 20 minutes a day being active. You kind of want to get your heart rate up, but first you have to find your resting heart rate, and he shows how to do that. In the next section, he talks about how to walk, which is kind of a funny thing. It threw me off when I saw the section title as I was reading through it. While most of us have been walking since we were children, what he shows here is how to walk to reduce the chance of injury or strain when you're walking for an extended period of time. And then the final section before the retrospective is getting out and actually taking the first steps. In the act on it section, he talks about walking to solve problems. I know when we were in school, Will and I used to do this quite often. And I actually had a conversation at work today when I was leaving because I was stuck on something. I said, you know what, I'm just going to go take a walk and then go home, get away from it, get a little physical activity. And when I got home today, I took the dogs out and ran around with them and just sort of ended up figuring out what the problem was and how to solve it. So a lot of times, Will and I would be halfway around the block when the solution would come to us back in college. So I'll have a link to that in the show notes. Will, who's talking to us this week?
Well, we got an iTunes review from ACBKPODDHS. I have no idea how that's supposed to be pronounced, so I'm just going to spell it out. Great podcast. Really enjoy this podcast. Informative and entertaining. Sweet and right to the point.
Yes. Thank you for the review and the words. We do our best to educate in a way that helps people remember what we're talking about. Send us an email to waterbottle@completedeveloperpodcast.com because we've got a Complete Developer water bottle just for you. Guys, if you'd like your very own Complete Developer water bottle, leave us a review on iTunes or comment on the website or any of our social media. We post all our episodes to Facebook, Twitter, and LinkedIn. We're also on Instagram and Tumblr. Join the conversation anytime via Slack by going to slack.completedevelopernetwork.com.
If you code for long enough, you'll eventually run across a code base that is difficult to deal with. Such code bases have a lot of downsides, with everything from bugs to being extremely difficult to extend or to troubleshoot. Worse still, management is unlikely to understand just how expensive such a code base can become over the long term. A code base like this can contribute to high employee turnover, make bug fixes slow, and even damage your product over time as it becomes harder to modify.
In this episode, we've brought Uncle Bob Martin on to talk about the principles of clean code. Not only will we be discussing software development practices that can help you keep your code clean, but we'll also be talking about what cost that bad code imposes on everyone and why it's a bigger problem than you might think, even if you've been in the industry for a while.
Uncle Bob probably needs no introduction, but we'll introduce him here just in case. He's been a software professional since 1970 and an international software consultant since 1990. He's the founder and president of Object Mentor Incorporated, which is a team of experienced consultants who mentor their clients worldwide in the fields of C++, Java, C#, and Ruby. He was also a co-author of the Agile Manifesto. Finally, he is the author of a number of software development books that we highly suggest you read. This includes Clean Code, Clean Architecture, The Clean Coder, Clean Agile, and there's several others in the mix there as well. He's a wealth of knowledge about how to properly conduct software development as a craft rather than as a mere job, while producing better code and better systems of the process. He changed the way Beej and I both wrote code early in our careers and did the same for many of our mentors as well. In fact, I think it was Clean Code was actually a required reading at my first job out of college.
So, Uncle Bob, before we get started with the questions that we want to discuss, something that we like to ask all of our guests when they come on, because we love origin stories, what first got you interested in computers and programming?
Oh my goodness. I was 12, and that would have made it 1964. My mother purchased for me a small plastic computer as a birthday present. This was a machine that had 3 sliding pieces of plastic that were called flip-flops, and they could go back and forth between 2 states, 1 and 0. They had little grooves on them, And there were rods on this machine that could slide into those grooves. They were spring-loaded. You could block them by putting tubes on pegs on the little flip-flops. So as the flip-flops change state, they might block or enable one of the rods to slip into the groove. If the rod slips into a groove, it enables a mechanism that changes the state of one of the flip-flops. And if you think about that long enough, you'll realize that's a finite state machine, a 3-bit finite state machine. Each one of those rods was an AND gate. It had 6 of them. So it was a finite state machine with 6 AND gates. And of course, I didn't know that. I was 12 years old. So for me, it was just putting tubes on the pegs and cycling the machine and getting it to do interesting things. You could get it to count in binary, count from 0 up to 7 and then back to 0. And another program you could put on it would make it count down from 7 down to 0 and then back up to 7 again. There were several other little programs you could get it to do. You could actually make it behave like a full adder. You had to put an OR gate in there in order to make that work. But okay, you could do that. I diligently did every experiment that this machine could do. They had a little manual with all these experiments. And at the end of that, after several days, I was very frustrated because I didn't know how this machine worked. I couldn't understand it. And I did not know how to make the machine do what I wanted it to do. At the end of the manual, there was a little paragraph that said, if you want the advanced programming manual, send in $1 and a self-addressed stamped envelope, and we will send it to you. So I did. I got $1 and I stuck it in an envelope, and I sent them an envelope for it. And 6 weeks later, there was no Amazon in those days. 6 weeks later, in the mail comes this little manual. It's really small, maybe 30 pages long, maybe not even that much, about the size of a comic book. I got it out and I read it several years ago, just to remind myself what it was like. It is perhaps the most cogent and effective tutorial on Boolean algebra that could be imagined for a 12-year-old audience. And it was completely unapologetic, right? It starts out with truth tables, Venn diagrams, Boolean variables, the associative properties, the distributive properties, De Morgan's theorem, right through the whole suite of Boolean algebra. And then it said, okay, now you've got this problem you want your machine to do. So write down the state transition table. They didn't call it that, but that's what I'd have to call it now. Write down the way the bits are going to transition. Convert those transitions into Boolean equations. Reduce the Boolean equations to lowest terms using the Boolean algebra we just taught you. And here's a little table where you can take those Boolean equations and use them to put the tubes on the pegs. So I did. I had a little program in mind. It was called Mr. Patterson's Computerized Gate. And I wrote down the truth tables. I converted them to Boolean equations. I reduced the Boolean equations. I put the tubes on the peg. I cycled the machine, and that little machine did exactly what I wanted it to do. And I was a programmer. That was it. From that point on, I knew exactly what I wanted to do with my life.
Nice. I like that. That's one of the best origin stories I've heard.
Yeah.
That's how it worked. I still have that machine. It sits on a bookshelf of mine with a place of honor.
That's cool.
That is a heck of an origin.
I couldn't imagine learning Boolean algebra at 12.
Let's see. I mean, I started messing with it, I think I was 14. But, at that point, you had a 486 or something like that. So it was a little bit, it was a little bit more black boxed, but you could get more help on stuff too. So it was definitely a different time. So I guess let's jump into the interview then.
Sure.
So when we say clean code, it's kind of common for software development managers to interpret this in a variety of interesting ways. So I think, how would you define clean code?
How do I define clean code? Heavens. It's a very interesting question. Clean code is best defined, I think, by Michael Feathers. Michael Feathers said, you are working on clean code when it looks like it was written by someone who cares. I love that definition. There's a whole bunch of other definitions that I put in the book, but that's one of my favorites. Because most of us, when we're reading code, can realize pretty quickly that the author did not care about us at all.
Right.
The author cared about getting something done as fast as possible and checking it in as fast as possible. and not about the after effects of other people who have to plod their way through this code. So I liked that definition. Clean code is written by people who care about you.
I mean, that totally fits. I have worked on some code bases that were complete dumpster fires. And then you switch over to one that's really clean, and like the difference in the way that you feel about the code that's a pretty solid definition. And being able to tell that the person wasn't just slinging code so that just to hit a requirement and make it go away, as opposed to, okay, we're building something for the long term. It does definitely make a difference. So what are some things, in that case that you see that indicate to you that a code base does have problems or that it's not clean code?
Okay, well, the very first indication that a code base has problems is that the code base has no unit tests. Right? First big indicator. And a code base without unit tests must be out of control. There's no way to control a code base unless you have a suite of unit tests to protect it. So the authors of a code base, the team working on a code base without tests, must have lost control of it. It must already be a mess. And the only thing that can be happening to that code base is that it's getting messier and messier with time.
Yeah.
It's the first big indication.
I've seen code bases where they had unit tests, but about half of them were commented out because, we changed this.
Yeah.
And so...
Oh, that's a good indication.
That means the person that cared left. That's what that means. Or management changed or something like that. I've worked on several where the only unit tests were actually extremely brittle because somebody was using the unit test framework as a task runner so that they could just click on the test and run it.
I see.
Yeah. So I feel like that's a little worse. Like, I get where you're going with that with the unit test as far as keeping the code base, in check. Are there any other things that, fit with that?
There's a load of things, right? You're looking at clean code if the names are well thought out. You look at them and you see names, and the names actually have meaning to you rather than, funny little abbreviations or A1, A2, A3 or something like that.
Do stuff.
Well, you know that you are working on clean code if the size of the methods are small.
Mm-hmm.
If you've got a lot of very small methods, it means that someone has taken the time to partition them and organize them well and so on. If you see a 300-line method, you know that the author didn't care. Right? They just slew a bunch of code into that method. They got it to work. And here's the problem. What happens to most programmers is that they think their role is to make the code work. Right? So they'll sit there and they'll fiddle and it won't work and it won't work. And they'll try to get it to work and, it's still not working. And all of a sudden it works. And they back away, they hold their breath, and they reach over and they check it in as fast as they can before they can break it. And this is exactly the wrong approach, right? When it works, you are not done. Kent Beck used to say, first make it work, then make it right. And that's the second half of the programmer's job. Once you get something to work, you aren't done. Then you clean it up. Then you reorganize it. Then you make it better. And doing that without a suite of tests is virtually impossible.
So I have a question on that. When you've got it to work and you have a lead or manager who says, it's working now, just put it in and move on to the next thing because you don't have time to clean it up. How do you address that?
Why would you tell them that?
Exactly. You're giving information to the enemy. Don't do that.
I have in the past been told that I spent too much time after I got it to work cleaning it up.
Yeah, and that's very common. People will tell you that. And you say, well, thank you for your input. So, here's the thing, right? You're the one whose butt is really on the line here. You're the one writing this code. It's your reputation at stake. Why would you let someone else talk you into shortcutting your own work? Even if he's your boss or she's your boss, it doesn't really matter. You are the one who is hired because you know how to do this. And so when someone comes along and says, I want you to sacrifice all your disciplines for my agenda, you say, well, thank you very much, but I don't think I'm going to do that. That's not good for me. It's not good for you.
Yeah, it's kind of like your boss telling you that you need to drive faster into the office when they're not riding in the car.
It's true.
Or even if they are, sometimes they don't care, right?
Yeah, there's that. Or they're not aware of just how bad a wreck can be.
Yeah. This is a fundamental problem, right? Programmers do not assert their own authority. They think they are working for someone they must obey implicitly. That is not the mark of a professional. A professional is someone that you hire in order to tell you what to do. You hire a doctor, the doctor's a professional, the doctor tells you what to do. You hire a lawyer, the lawyer is a professional, the lawyer tells you what to do. If you want to stay out of jail, I suggest you do what the lawyer tells you to do. And it's the same with programmers. You hire programmers because they know, and they're going to tell you what to do in order to get the best possible outcome of your project.
Will, I think you were the one that told me, and you probably got it from somebody else knowing you. This was back when I was first getting into it. You were like, as a programmer, your job isn't to type. Your job is to solve problems, mostly with code.
Yeah, and I would almost back off of even saying mostly now at this point. Because like there's so little of it that's the actual code. Like most of it is people problems.
Yeah.
You know, just sometimes they're expressed in code. I would lean towards that. But
on this topic, when talking to management or lead developers, the people that make the decisions as to how to spend your time, what are some common mistakes that developers make suggesting code cleanup?
The biggest mistake that programmers make is asking for time to clean up the code. We need a week. We need a week. Just let us work for a week to clean up the code. It's a complete disaster. It's absolutely the wrong approach. The week is not long enough. You'll actually mess the code up more than you would have. And the people you asked permission for will never trust you again. Code cleanup is not something where you set aside time for it. Code cleanup is something you constantly do all the time, every minute, every 2 minutes, before every check-in, always cleaning the code. It's not something you put on a schedule. You never put the word refactor on a schedule. You never put the word cleanup on a schedule. You're always doing that. Why do programmers do this? Why do they ask permission? And the answer to that is they don't want to be blamed. They want the managers to take responsibility for what they know they should do. It's a very unprofessional and a very immature way of behaving. If you're a programmer, you know what needs to be done. You know that there's cleanup that has to be done. You just do it.
Yeah, that matches with my experience as well. Like I've been at this for longer than I want to admit. And one thing I see all the time is like the developers that, you know, they'll go and ask permission for stuff it's like, dude, you're getting a 6-figure salary. Why are you asking for like that? Breaks management's confidence in you before you do anything.
Yes, it does.
It's like I said, it's mostly not code. It's mostly people problems. Like I'm at the point now, I'm not even sure I'm a coder. I think I'm just like, that just is the expression of how I fix things sometimes.
Well, programming is a human activity, and it requires that you understand human nature to do it well. A lot of times we like to think of ourselves as loners who sit in a room and we just kind of write if statements and while loops. But there's no way to be an effective programmer unless you are good at communicating with other people and understanding what your role is in the organization. And the role of a programmer is not what most programmers think of it.
So I guess, you know, when we get to misconceptions, like what are some misconceptions that software development managers typically have around code cleanup and building robust systems? I mean, especially like managers that haven't written code or they haven't written it in, 20 years, or, they were developers, but they got promoted into management before they got to be really good at development.
Biggest misconception that managers have about programming is that any date can be set for certain, and that you can meet a date by pressuring the programmers to go faster. Pressuring programmers always makes them go slower, always makes more bugs, always makes more problems. The best way to let a project, or the best way to run a project, is to measure how fast the programmers are going,
right,
long before you set a final end date. Or if you have set a final end date, measure how fast the programmers are going and then trim scope like crazy, because you're not going to get half of it done.
And it may just be the developers I've worked with, but I think it's kind of common in the industry. The one thing I've noticed is effective, at least it's effective with me, my coworkers, is give us a challenge rather than say you have to get it done by this date. Say, all right, you've got this extra time to do it, but I don't think you can get it done before then.
Yeah, I've been on the receiving end of that. Not as much as I've been on the giving end of that, though, because it works with the right kind of people. But the wrong kind of people, like that puts pressure on them and they won't. I know several members of your team.
Like I said, I think it's probably not everyone, but part of it too is if you can get them to challenge themselves.
I've been on some interesting teams where that would not, because they would have been like, yeah, you're probably right.
Too.
And they would just agree with you. In fact, we can't get it done in twice that long. So,
yeah, I know some people that you've worked with.
We've been friends for a long time.
You guys know too much about each other. Yikes. So I write a lot about this in the book Clean Agile, which is mostly about this problem of how do you run a software project? How do you measure how fast the people are going? How do you manage the scope? Which all relates back to the whole Agile thing that started 20 years ago.
Yeah, I think sometimes too, this might be a worthwhile thing to talk about, is the way managers misunderstand Agile is also kind of in the mix there, because a lot of them think that, well, we don't have to have best practices. We don't have to do clean code. We don't have to have unit tests, but we should be able to turn stuff around real quick because we're Agile. It's like literally you have none of the processes, but we call it that. So therefore it's magic.
We very likely should not have named it Agile. It was the least satisfying a bunch of very bad alternatives at the time. We all kind of voted for different names, and Agile was the one that everybody hated, but we kind of went for it anyway. The implication, unfortunately, is that it's about going fast, which it is not about. Agile is not a way to go fast. Agile is a way to know how screwed you are early.
Yeah.
I like that.
That is totally on point. Oh, man. Like, I can't wait to share this.
I was just thinking, I'm looking forward to quoting that at work.
Yeah. Be like, look, we know a guy. He'll back us up. Oh, man. So let's just keep rolling on the questions. I mean, I have Mir's general guidelines, but so how do you balance code refactoring and cleanup with the need to roll out new features? Like, for instance, I've worked at a company that sales determined all the timelines and nobody asked development. It was great. You had nested cursors within cursors. You had business logic in SQL Server, no unit tests whatsoever. And they just copied and pasted code to do new things. And, copy, paste, modify, and go on. So how do you balance that? How do you work with management in such a way that that doesn't get that pathological?
Let's see. We have an insane person running the company, and they're creating completely ridiculous deadlines that they don't talk to the programmers about. They just kind of drop them on the programmers. How do we deal with that? Well, the first thing you do is you don't satisfy those demands, right? Because if you satisfy the demands, you're just coming back to them and saying, yep, you were right. We actually can do this.
The nice thing about that is those demands are pretty easy to not satisfy because of, physics.
Yeah, generally they don't get satisfied anyway. But if you even acknowledge them, if you say, okay, we'll try, you have already told your biggest lie, because you're not going to try. There's nothing you can do to actually make this work. And you've led the person to believe that they were right. And you've tacitly guaranteed that you're going to do it. To a completely unreasonable demand, you cannot start out by saying, okay, I'll try. What you have to do instead is say, no, that's a completely unreasonable command, or a completely unreasonable demand, and there's no way we're going to achieve that. Now, here's what we can achieve, but we're not going to achieve that. And then begins the negotiation, and it's a difficult negotiation. Programmers aren't good, and I'm speaking in general terms here, but programmers are not good at confrontations. We like to deal with the keyboard. Keyboard's predictable. We know what the computer's going to do, but these people, we don't know what people are going to do. Most of us didn't get into this business because we want to work with people. As you said, it's always a people problem. It's always learning how to react to people. So when you've got an unreasonable manager making these crazy demands, you have to be able to look that guy in the eye and say, no, that's not going to happen. We're going to have to come up with a different solution. I learned this the hard way, and I learned it in a meeting. I was actually running a group at the time. I had a group of 10 or 12 programmers, and I was in a resource allocation meeting with a bunch of other managers. And I had made promises to my customers. I knew what I could get things done for them. I knew it was going to be okay as long as my resources weren't rated. And I sat in this resource meeting with the other managers, and I watched as one by one, they were going to steal resources from me. I'm a programmer. I don't like to confront people. I don't want to read them the riot act. But as they worked their way through the logic, which I could tell was going to rip people out of my team, my face got red. I got angry. And all of a sudden in this meeting, I lost it. I just lost it. I started yelling at them. I started telling them all the bad things that were going to happen because this customer was going to get so irate after all the promises I had made. And after a while, I sat down and I thought certainly I was going to be fired. And I was stunned at their reaction. They looked at me and they said, wow, you've made a very good point. There are people who find the truth by confrontation, by looking at your emotional reaction to confrontation. That's how they find the truth. Programmers find the truth mathematically. We look at engineering stuff. We know the truth because the code says it or the logic says it. But there are people, and they tend to be managers and salespeople.
Or sales managers, for that matter,
They find the truth by pushing you to an emotional limit. And if they can get you to that emotional limit, then they found the truth. And they'll back off at that point. Okay, that's where the truth is.
That's actually some pretty good insight on some experiences I've had in the past where I did not handle it well because I was trying to go along to get along and, basically screwing your team over if you do that because, it's not just you. You end up making them carry the weight.
Well, I think something that you said, it really stood out to me. And that is you address what they're saying and you say, no, that's not possible. But then you come back with, here's what we can do, knowing that that won't be acceptable and it's going to become a negotiation.
Yeah, so you build a negotiating position.
It must be a negotiation about what is possible. So, yes, you come back and say, well, this is what we can do. You cannot let the negotiation then take you over back into what cannot be done.
Exactly, yes. It's like I was at Bargain Hunt the other day. I was going in looking for a ugly Christmas sweater for a party. I was in there looking for this, and I saw this really nice camera, like photography lights, and a $200 set of photography lights that they had for 60 something because the box was open. All the pieces were there. But I looked at them like, I'd pay like $50 for that. So I went up to the counter and I said, hey, I'll give you $30 for it.
Yeah.
We negotiated back and forth, got it down to about $45. I'm like, all right.
Well, and I think that's probably the key, right? Because the thing that a developer is likely to do is to say, okay, here's what we can get done. And they don't sandbag it to think that they're going to get negotiated against. And I know that has been something that has burned me a lot in the past because it's like, well, I feel like I'm being dishonest, but really, it's part of the dance.
So that's what Scotty, right? Scotty on the Enterprise. He said, always tell them it's going to take you 3 times longer. I actually don't like that advice. I don't want to multiply things by 3. My approach is a little bit different. When people ask me for a date for how long something's going to take, I give them a range, and it's a probability range. I say, okay, the most likely scenario is that it's going to be done in 4 weeks. There's a 5% chance it's actually going to take me 10 weeks, and there's about a 5% chance that I'll be done in 2. It's a pretty reasonable thing to do, right? You provide this range of probabilities. Now, managers don't like probabilities. They want certainty. So they'll push back on you and say, well, can't you just give me a date? And the answer to that is no. What I can do is give you a range. And this range, I think, is probably pretty good. And by the way, as time progresses, I'll be able to narrow the range down a little bit.
That makes a lot of sense, just given the times I've been given a small project to work on my own where I got to say that to management of like, how long is it going to take? I didn't even think about it, but I kind of did that. I was like, if I figure it out and it works the first time, it's going to take this long. If not, it could take, up to this long. I like that though.
I feel like that's probably better than tripling too, because the thing is once they catch you tripling the estimate, then they just divide by 3 every time you give them one. So like, you almost need to randomize the multiplier every time so that they never know for sure.
One thing that you mentioned earlier, I want to kind of hit back on because Will has a good question about it in here, is naming things. And so, how important is it to name things correctly in a code base? And why is it important to change the name of things so that they're more descriptive?
I once asked Grady Booch what clean code was. And Grady came back and said, you're working on clean code because it reads like well-written prose. And that struck me. I thought, how do you get code to read like well-written prose? And the answer to that is that you start naming things very, very well, and you name a lot of things. So, for example, if you have an if statement, what do you put in the parentheses of the if statement? Do you put some ugly Boolean expression? Or do you take that ugly Boolean expression and put it in a method that has a very nice name? Then if it's in a method that has a very nice name, then the word if leads into this nice name. If employees should be given a raise, ? That would be a nice if statement, right? The body of the if statement could be a single function call. That function call could be to a function that has a nice name. The else side of the if statement could be a function call to a function that has a nice name. When you start using names that way, the code begins to read. You can start to read it. And the words well-written prose probably aren't quite right, but it starts to read well enough that you can read along and understand the intent of the programmer. So one of the guidelines in the clean code book is extract methods. Everybody's got an IDE now that has an extract method refactoring. So you select your code and you extract it into a method that has a nice name. The bodies of all the if statements, the parentheses of all the if statements, the parentheses of all the while loops, extract, so that the code you've got is a bunch of very nice names of functions and variables composed with if and while loops instead of a long linear list of a bunch of primitives.
That sounds awesome. The thing is like when you're in a crazy situation, the situation that isn't as crazy can look insane.
Well, yeah. And like I could see people who are used to doing more procedural things being confused by that. It makes a lot of sense to me. And I love it when methods and functions are named in such a way that I do not have to look at the method to know what it does.
And where I can trust that the name is accurate because the rest of them are.
Yes.
Is the other thing. So like it has to be a consistent practice, or it doesn't add anything until it's a substantial portion of the code base that's that clean. Because if you're looking at it going, well, this says, toggle this flag, but does it toggle this flag or does it toggle this flag and send an email?
Or does it send an email and not toggle a flag?
Yeah, well, there's that.
Or is it something like you've got one method that is hungry and returns true if hungry.
Yeah.
And one method that is thirsty and returns false if it's thirsty. Where they should have put like is not thirsty or just switch returns. But you get that's a really dumb example, but you get what I'm saying, where they change the way it returns or what it returns, and that can get confusing.
I've been there and done that. Of course, I've also worked in environments where having a function that calls another function was considered bad because people were fixated on the old, if you have a single pass compiler and, the compiler doesn't inline things, then it's technically slower because you're pushing stuff onto the stack and yada, yada, yada. And people are still fixated on that in the current year. So I've been on the other side of that. And I feel like there's almost some industry-wide practices sometimes that make it harder to get your code clean.
I grew up on the other side of that. I grew up when function call was 5 microseconds. And so you didn't do that. You didn't make long chains of calls because it would destroy the productivity of the system. But that was a very long time ago.
Well, I've worked on Delphi this year.
Yeah.
And so that's very prevalent in that environment, just because that's, those developers dealt with that and that's when they learned it. And so
In the 80s, yes.
Yeah.
Yeah.
But
and all the Delphi programmers came from the 80s.
well, the programmers don't unlearn things very well either. So when the situation changes, we tend to react with what we already know. It's kind of like
The
self-defense.
situation has changed remarkably, right? A function call nowadays is sub-nanosecond. And if you're worried about that today, you're worried about the entirely wrong thing, especially if you're coding in Java, where you're running on a virtual machine. So those kinds of thoughts are extremely ancient. And you're right, we do get caught up with those old thoughts, and it's very difficult to shake them. The strategy that I use for that is, and this again goes back to Kent Beck, first you make it work, then you make it right, then you make it fast.
Because you can.
And by making it fast, maybe you have to undo some of that extraction that you did. Maybe, deep inside an inner loop, maybe you have to pull some of those functions back together.
Well, I would also think that your approach of breaking things into really granular methods makes it a lot easier for performance tools to get metrics around what the hot spots are.
Sure.
And those kind of things. Otherwise, you're looking at from this memory location to this memory location, in the executable, and that's it. And you got to go try to figure out where that is versus this function call is taking too long. What can we do to trim that? So it would seem that the more granular approach would kind of make that easier.
Yeah. It would also make it easier to, going back to the very beginning of the conversation, to create unit tests.
Well, and that's the other thing too. If you can create unit tests, it also makes your load testing, like you can just beat the crap out of that one method and see if you've actually sped it up because it's just that one little piece versus, a 3,000 line method that, has go-tos everywhere.
Yeah.
So are there any industry practices that do make it more difficult to clean up a code base that you've seen, especially, nowadays? I feel like we've got our act together compared to the way we used to write code in the late 90s and early 2000s.
There are a number of products and platforms that make it hard or impossible to write tests. Usually these are very large business-oriented platforms that offer the ability to write a little bit of code in them. They are sold to executives as, this solves all your problems and you're just going to need a couple of programmers to twiddle things a little bit. And then, of course, what you really need is an army of programmers because you have to twiddle a hell of a lot. And those platforms very often do not make it easy to write tests or actually make it impossible to write tests. Those kinds of things in today's environment make it very difficult to keep a software system clean. Modern languages, however, do not. Modern languages are terrific. Java, C#, Python, Ruby, Clojure, Go, Kotlin, Dart, Elm. These languages are very, very pleasant, very easy to use. Writing tests for them is trivial. So all of these languages can be used in a very clean environment.
Yeah, I get what you're saying about those big enterprise systems, though. I've just had to deal with LexisNexis in the recent past with their mainframe system calls where you open a socket and you talk over a VPN and you get a payload back that, could be anything. And it's horrendous to try to test that stuff. So I totally get you there.
And if you can't test it, you're going to lose control.
Yeah. And speaking of losing control, how does error handling fit into the picture of writing clean code? Like, how do you have robust error handling without making it hard to follow the code because, the error checking code is everywhere?
Well, we've got this new technology called object-oriented programming. It's just brand new. Hardly anybody knows how to use it right now. Of course, I'm being facetious.
I don't know. That last statement, I could probably back that one up with some things I've seen. But
it turns out to be relatively simple to isolate error handling from normal processing code just by using normal inheritance techniques. So you have a class in which you can detect some errors, and you have a derived class that does all of the error handling. Those are just simple ways of approaching the problem. The same thing with logging, by the way. If you've got a lot of logging you're doing, it's fairly simple to write the normal code in a base class and then do all the logging in a derived class.
Uh-huh.
Those are pretty trivial techniques. There's a lovely book that people don't read, unfortunately, called Design Patterns, was written in 1995. It is probably the most important book written in the last 30 or 40 years.
Mhm.
And the answer to those questions is well answered within those pages.
So, we just were talking about error handling. We've talked about unit testing. When you step into a code base, you come upon it and it does not have unit testing, severely brownfield.
You step into the brownfield.
Yeah, right. How would you start to bring unit testing into that code base?
So this is the question everybody has, because it's the problem that everybody has. Everyone is dealing with a massive wad of legacy code that doesn't have unit tests. And the obvious question is, well, okay, now I know how to do it right, but I've got this mess. So my first piece of advice is, do not start a project to clean this up. Do not start a project to add tests. Those projects will always fail. You never have enough time to do them properly. So what it requires is a shift of attitude. And this attitude shift must be by every programmer on the team. And the attitude shift is a simple one. I call it the Boy Scout rule. Every time you check the code in, you check it in a little better than when you checked it out. Every single time. You never check it in worse. You always check it in just a little bit better. Do some random act of kindness that makes it just a tiny bit better and check it in. The problem here is that the risk of making changes is enormous. So no one is going to be making wild refactorings or adding loads of tests. The other problem is that most of the tests you'd want to add, you can't add because the code is so coupled, you can't test the things you want to test. So what you need to do is very gradually, one tiny improvement after the next, make the code a little less coupled, a little bit easier to test. At some point, and this is probably weeks or months later, you may be able to add the first test, or maybe a couple of tests. And then the next person will come along and maybe be able to add a couple more. And bit by bit, you're going to add tests and improve the code in the part of the legacy code that is changing. There's a whole bunch of code in that system that doesn't change. It hasn't changed for years. It's never going to change. It works. Don't touch it. There's another set of code, a layer of code that you're always fiddling with. And that's the layer that you'll see improvement in. This is a very gradual process. It takes a very long time. I don't want to give anybody the idea that there's a quick solution. There isn't. It's going to be painful and hard, but you can make improvements. And the more improvements you make, the easier things get. There is a lovely book that describes this process. It's written by Michael Feathers. It's called Working Effectively with Legacy Code. It is the most depressing book you will ever read.
Mm-hmm. Yep, it was required reading at one of my jobs. I forget which one, but yeah, the worst was like you see something in the book, your manager recommended that you read the book, and then you're looking and seeing him make the code worse. That was the thing that got me. It was like, oh man, ouch. Yikes. So we often use the term technical debt to describe code bases that have grown wild due to poor maintenance. Is this analogy still a good one, or would you use something else?
This is the analogy that was invented by Ward Cunningham probably 20 years ago. He talked about the fact that a team of programmers will borrow against the future in order to get a deadline done. He termed that technical debt. And there's been quite a bit of debate about that since. Is this a good term? Martin Fowler came around a little bit later and said, well, there's two axes here. It's not just technical debt. There is responsible technical debt, and there is irresponsible technical debt. And he made the analogy, and it's a very good analogy. Responsible debt is like when you go out and get a mortgage for a home. And you've done all the work and all the analysis, and you know you can make the payments, and you know you can deal with the interest, and it gets you the home faster, much faster. And so that's responsible technical debt. And you have a plan to pay it back, and you know how you're going to do it. Irresponsible debt, or irresponsible technical debt, is the teenager with a credit card who just suddenly realizes they've got free cash, and they go out and they buy anything they want without any thought to the payments, without any thought to the interest. And then a year later, they find themselves with a $10,000 debt that's earning 14% interest, or charging them 14% interest, and they have no idea what to do about it. Is it possible to accrue responsible technical debt in a software project? And the answer to that is, of course, it is. There are things that you might want to do for an application, but they're going to be too expensive. And there are other things that are less desirable, but they will at least allow you to get started. And so you do the less allowable, the less desirable thing to get started, knowing that you're going to have to take it out and replace it with something better later. And that would be a responsible technical debt. And a good example of that is, you want a nice fancy drag and drop GUI, but you could get a product out there with HTML frames. Okay, nobody wants HTML frames in their long term, but okay, you could probably do that for a few months and then replace it later. That would be responsible technical debt. And in that case, the code is well structured. You have tests. All the disciplines are used. You're simply doing something suboptimal in a responsible way. The irresponsible technical debt is the guy who says, I've got to have it next Tuesday, and all the programmers throw away every discipline in their world to get it done by Tuesday. They make a terrible mess. They ship it, and they think they've done something wonderful. That would be irresponsible technical debt.
So on that responsible technical debt, in your example, would you make refactoring that a project if that's the plan all along?
Well, that wouldn't even be a refactoring at that point. That would be a fundamental design change. And yes, that would be a project. The transition from frames to a drag and drop GUI.
Yeah.
Yeah.
I was going to say, that's like 20 years.
True. Yeah. True. So the last thing we want to ask is, how would you characterize the difference between software development as a mere profession, a 9 to 5, and software development as a craft?
Okay, interesting choice of words. Let me turn that around a little bit. You use the phrase a mere profession. I'll turn that back at you. A profession is something that you profess. What do we software developers profess? What set of standards, what set of ethics, what rules, what disciplines do we profess? And the answer to that is nothing. We profess nothing. We do not have a profession. We have a trade. Barely even that. It should become a profession. We should have standards that we profess. We should have ethics that we profess. There should be disciplines that we profess. We simply don't at the moment. So I'll take exception with your use of the word profession. And then I will say that a profession and a craft are the same thing. A professional is a craftsperson. Now, let's go back to the beginning. Is programming a 9 to 5 trade, or is programming a profession? Is it a craft, a profession? And the answer to that is, at the moment, for most programmers, it is a 9 to 5 trade. They're clocking hours. And when they're done, and that's it. And there's a certain level of passive aggression to that way of working. It's the employer's problem. It's not mine. I just come in from 9 to 5. That's it. The professional takes a very different view. The professional owns the problem. The professional is in partnership with the employer. The employer has hired the professional to be a partner. And so there's a high degree of responsibility and ownership that the professional takes in getting things done. Therefore, it is not a 9 to 5 job. It is not a paycheck gathering job. It is what word could I use other than a calling? Certainly that's the way I've felt about it for over 50 years now. It's something that I am passionate about, that I feel is a calling, that I spend my days and nights thinking about. So if that answers your question, I hope that's sufficient.
Yeah, that really does. I sometimes view being a software developer as an artisan. So we get to create and we get to make things that other people use. And it's just so cool. I love it. And it's something that I really enjoy doing. So first off, we want to thank you for coming on and answering our questions and teaching us. Like I know Will and I both learned a lot just from this conversation. So thank you very much.
My pleasure. It's been a lot of fun.
Guys, having a clean code base is like having a clean house. It isn't something that just happens, but rather the result of intentional decisions made, and most importantly, follow up upon over a long period of time. Clean code bases provide significant value to organizations and help software systems become assets for a company, while poorly maintained, messy code bases are often serious liabilities. That pretty much wraps us up. Before we close everything out, Will, what do you have for us this week for Tricks of the Trade?
Well, I just want to emphasize something that came up time and again during this interview, and that's the notion of having a sense of responsibility towards the other people on your team, towards just the code base in general, and being focused on that and going, okay, I have to make this thing better. It's not going to get better on its own. It's going to get worse if I don't take responsibility, if I push that off. I think that's kind of the overriding thread here that makes this whole thing work. If you want clean code, that starts with responsibility at the personal level, and then eventually, hopefully, getting to the rest of your team. But it kind of has to start with you. Otherwise, you aren't going to be able to fix it. So I guess that's kind of the point that we ultimately try to get across as we tell people to clean up their code base. Is it's really the equivalent of telling somebody to clean their room. Mm-hmm. It's, hey, this is yours. You want it to not be a dumpster fire. Maybe don't make it a dumpster fire. That's all I got.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@CompleteDeveloperPodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up for weekly emails with extra tips and insights, be sure to check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with news about the show. Catch us each week as we broadcast live, talking about what's going on in the tech world and answering listener questions.
Learn more about all of our shows and groups by going to CompleteDeveloperNetwork.com, where you'll find links to Junior Developer Toolbox, Developer Launchpad, and our other communities. Thanks for listening. See you next time.